Hello, this is Mrs. Ward, and I'm going over section 9.5, the binomial theorem. And we're going to use the binomial theorem to calculate binomial coefficients, use Pascal's triangle to calculate binomial coefficients, and use binomial coefficients to write a binomial expansion. So the first thing you probably need to know is what a binomial is. And a binomial is anything that has two terms. So I've written the binomial x plus y, and I've raised it to increasing powers, so to the 0 power, first power, second power, third power. And when I wrote the expansions next to each one, and I wanted you to see if there's any patterns that you can recognize. So one thing you might recognize is that the very first term of the expansion is going to be the first term of the binomial raised to whatever power that I'm raising the whole binomial to. So if I go to do this, I know the first term is going to be x to the sixth. Then something interesting that happens is that when I look at any exponents along the way, like this y is understood to be 1, if I take 3 plus 1, that's equal to 4. That's the power that I'm raising it to. If I take 3 plus 2, that's equal to 5. And that happens no matter what pair of exponents I look at. I also notice that my last term in the expansion is always the second term of the binomial raised to that power that I'm raising it to. And then another thing I happen to notice is that the second term is going to be, the coefficient of that term is going to be the power. So here I'm raising this to second power, that's a 2. Raising this to third power, that's a 3. Raising this to the fourth power, that's a 4. So I would assume that if I'm expanding x plus y to the sixth power, the next term is going to be 6. I notice that my variable, my degrees for x go down 1, so this would be x to the fifth. Remembering that rule where I have to have them add up to 6, and this would be y to the first. And then we're going to figure out how we find these other terms. I know that I'm going to end up with y to the sixth. I'm also going to know that if I have a 4 here, the second to the last term is also going to have a coefficient 4. So going backwards, I know the term before y to the 6th would be y to the 5th, have to add up to 6, so this would be x to the first. If this has a coefficient of 6, this would also have to have a coefficient of 6. And then I would know that my other terms would be x to the fourth, y squared. Then I would have x to the third, y to the third, x squared, y to the fourth, and then it would have x, y to the fifth. And then these coefficients we're going to figure out later on, but they end up being 15, 20, and 15. And yes, they are symmetrical. Like as you go to the left to the right, they look the same. And we'll go over how we find those out. So let's get started. So the binomial theorem says that if I'm expanding the quantity of x plus y, and I'm expanding it to whatever power, I am going to do the combination. And this terminology and this notation should look familiar from doing probability last year. It was the combination, 7 items, choose 3, that type of thing. So what I'm going to do is to find the, so if I'm raising this to the nth power, I am going to find the coefficient that goes in front of here. I'm going to do the combination and choose R. So let's go over how we find a combination, just see if you remember. So to do a combination, you're going to start with 9 factorial in the numerator, and then you're going to take 9 minus 2 and get 7 factorial, and then 2 factorial. So the bottom two, 7 plus 2, should equal this 9. Then I'm going to simplify it. Well, remember we talked about this before. This would be 9 times 8, and then I'm going to make this 7 factorial. This will be 7 factorial, and then 2 times 1. The 7 factorials will simplify, and then I can even simplify the 2 and the 8, and I would end up with 36. So a shortcut for writing combination instead of writing the C would be this 11-4. It's still combination 11-4. That's what that means. So I'm going to have 11 factorial on the numerator. Then I take 11 minus 4 and get 7. And then 4. Again, the 7 plus 4 have to equal the 11. think of 11 as 11 times 10 times 9 times 8 times 7 factorial. I'm stopping at 7 factorial because that's what will simplify. And then the 4 factorial is 4 times 3 times 2 times 1. Simplifying what I can. So the 4 times the 2 is 8. So that's gone. And then 3, 3. And when I do all this wonderful, glorious math, I get 330. At least I hope I do. This one's combination 8, choose 0. So I'm going to have 8 factorial. 8 minus 0 is 8. And then 0 factorial. I know that the 8 factorials will simplify. And then remember that 0 factorial is defined as 1. So this would just be 1. So to find the binomial coefficient, you're going to do the same thing. So if I have 10, choose 3, if I would do 10 factorial over 10 minus 3 is 7 factorial, 3 factorial, then that would equal 10 times 8 times, whoopsie, times 9 times 8 times 7 factorial. 7 factorial, 3 times 2 times 1. The 7s will equal 0. 3 and the 9, 8 and the 2, and this ends up being 120. When this one, doing this coefficient, I'm going to do 10 factorial. 10 minus 7 is 3 factorial over 7 factorial. And even though the work is technically different, I'm still going to end up with 120 because this doesn't matter the order that I write these two in. And that's why when I do the binomial expansion, it's kind of like a mirror image because it is. So here's 11 factorial. 11 minus 1 is 10, and then 1 factorial. So this would be 11 times 10 factorial over 10 factorial times 1 factorial, which is just 1. These will just be 11. So when I do 11 factorial, 11 minus 10 is 1 factorial, 10 factorial. So it doesn't really matter the order that I write the denominator. I'm still going to get the same answer of 11. So you're going to see that notation to find the coefficients of the expansion. So let's talk about Pascal's triangle, because as I said before, it's like the left side looks like the right side. So we have this triangle, which is Pascal's triangle, and we've talked about it a lot in class. So in order to expand this, first I'm going to add, I start with a 1, and then I start with a 1, start with a 1, and then to get, I have 1, and then I go up here, and the 1 plus 1 is equal to the 2, and I end with a 1. So to find the next row, I would start with a 1, add the 1 plus 2 and get 3, 2 plus 1 and get 3, and then end with a 1. So I'm always going to start with a 1, always going to end with a 1. When I go to do the next row, I'm going to start with 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4, and then end with 1. So sometimes you have this oddball middle term, and sometimes you don't. So 1, 5, 10, 10, 5, 1. And I can keep on going because it's quite enjoyable. I just want to point out a couple things. First of all, when I do this, this is actually row 0. This would be row 1. This would be row 2. And the easiest way to find out what row you're on is the second number tells you what row. So this is going to be row 3. And this is also going to be the expansion of x plus the coefficients for the expansion of x plus y to the third power. So the power matches the second number, which we talked about before. That was the coefficient of the second term, was the power that you were raising it to. So here's Pascal's triangle. You know how to figure it out. You don't need to memorize it. You just need to know how to figure it out. So if I ask you to write the sixth row of Pascal's triangle to find the binomial, you're going to actually know that you want the row, I'm going back to this page, you want the row that the second term is 6. So you want this row right here. I don't don't know why it's taken so long to draw, but that's the row that I want. So I'm just gonna go over and write that, maybe. So this would be 1, 6, 15, 20, 15, 6, and 1. And if I were to do any one of these, so let's say I did this one, 6 combination 3, so 6 factorial over 3 factorial, 3 factorial. So this would be 6 times 5 times 4 times 3 factorial over 3 factorial, and then 3 times 2 times 1. So this is 6. 3 factorial, simplify it, and I'm left with 20. And that's going to be there. There's something interesting that I want you to know too. When I do these combinations, this is my first term. This is my second term, and I know you know, but I just want to show you, point something out. So when I do this, and I'm raising something to the 6th power, I actually have 7 terms. And when I go to figure out what term I'm on, this number here is always 1 less than the number of term that I'm on. So if this is the 5th term, then the second number here is going to be a 4. That also coincidentally is going to be the power that I raised the second number to, but I'm getting ahead of myself, so I'll just be quiet. So if I go to write the expansion of the expression of x plus 1 raised to the 4th power, and this is like the baby one, this is the easiest we can get. So when I start to do this, I'm going to do that combination 4, 0, combination 4, 1, combination 4, 2, 4, 3, and then finally 4, 4. I could do all that, or I could just go back to Pascal's triangle and see that it's 1, 4, 6, 4, and 1. Up to you how you do that. If I'm raising something to the 4th power, I think it's a lot easier just to do the triangle and find those coefficients. If I'm raising something to the 57th power, I might not want to write 58 rows of Pascal's triangle. So remember, the first term is going, and the first one we're going to do the box method, which I don't know if anyone likes, but here we go. So here are my coefficients, and then I have x as my first term and 1 as my second term. So if I'm making this box, I'm trying to be neat, but you know, not. This will be x to the 4th, x to the 3rd, x squared, x to the 1st, and then x to the 0, which we all know is equal to 1. The 1 just goes the opposite way. So these exponents went down. The 1 exponents will go up. So this will be 1 to the 0, 1 to the 1st, 1 to the 2nd, 1 to the 3rd, 1 to the 4th. Remember that these powers always have to equal this exponent. Then to find the expansion, I'm going to multiply down. So 1 times x to the 4th times 1 will be x to the 4th. Then 4 times x to the 3rd times 1 will be 4x to the 3rd plus 6x squared plus 4x. And then this will be just plus 1. And that's the expansion using the boxes. So that is an easy one. So if I want to do, if I want to do x minus 2 raised to the 5th power, I'm going to do the combinations, or I'm going to do Pascal's triangle, and I'm going to choose to do Pascal's triangle. So I would have a 1, 5, 10, 10, 5, and 1. You know what? I'm just going to go ahead and put plus signs here. I don't know where I want to put the plus signs. From there. The next thing I'm going to do is I'm going to do my x. So this will be x to the 5th, x to the 4th, x to the 3rd, x squared, x, and then this will be x to the 0, which is 1. Now the next one, I'm going to have to take that sign into account. So I'm going to think of this as -2. So this is actually, I ran out of room, -2 to the 0, negative 2 to the first, negative 2 to the second, negative 2 to the third, negative 2 to the fourth, and then negative 2 to the fifth. So to find my answer, I am going to take 1 times negative, this is 1, so this will end up being just x to the fifth. And then I'm going to have 5, x to the fourth, negative 2, so this will be negative 10 x to the fourth. Then I'm going to have negative 2 squared, which will be a positive 4, so this will be 40 x to the third. Negative 8, negative 80 x squared. Positive 16 plus 5, so positive 80x. And then negative, because it's raised to an odd power, and that's going to be 32. And that's my expansion. So that's without doing the boxes. It's just doing term by term. So to do the next one, I'm raising it to the fourth power. My coefficients raising something to the fourth power are going to be that 1. I'll try and give myself more room. Plus 4. Plus 6. Plus 4. Plus 1. And that's just going along Pascal's triangle. Second term is 4 because I'm raising it to the fourth power. So then this now will be 3x to the fourth, 3x to the third, 3x squared, whoopsie, put it like that, 3x to the first, and then 3x to the 0. And then the last one will be this negative y. So this will be negative y to the 0, negative y to the first, should put that in parentheses, negative y squared, negative y to the third, negative y to the fourth. Remember, at any time that 1 plus 3 has to equal to 4. Now I'm going to try and do this. So I'm going to have 3x to the fourth. So I have to raise that 3 to the fourth power, which would be 81. So this will be, and the y to 0 is 1. So this will be 81x to the fourth. 3 raised to the third power is 27. 27 times 4 will be 108. This will be a negative, so negative 108 x to the third y. And I really think this one would probably have been easier to do with a box. So y squared, so that's going to make that a plus. There's y squared, x squared, and then 3 squared is 9 times 6 is 54. Then this will be a negative, and you should notice that if this second term is negative, your signs are going to alternate positive, negative, positive, negative. So it's going to keep on with that pattern. This will end up being 12x y to the third. That's a 12. And then finally, the last term is the 3x to the 0 is just going to be 1. So this will be plus y to the fourth. And that's the expansion of that one. Write the expansion. This one's slightly different because it has a term that's raised to something other than 1. So still same pattern. I think this one, let's just go back to the boxes. So first thing I'm going to do is write my coefficients, which are going to be 1, 5, doing the fifth row, Pascal's triangle, 10, 10, 5, and 1. So I'm making my box. I'm not even trying to be neat. This is going to be my 3, so this will be 3 to the fifth, 3 to the fourth, 3 to the third. Notice that the exponent goes down. 3 to 0, this is 1, this is 3, 9, 27, 81, and 243. Then I'm going to do the second term, which is this negative x squared. So this is negative x squared to the 0, which is just 1. negative x squared to the first, which is negative x squared, negative x squared squared, which is x to the fourth, negative x squared to the third, which is negative x to the sixth, negative x squared to the fourth, which is positive x to the eighth, and negative x squared to the fifth, which is negative x to the 10th. Now, multiplying, and I'm trying to be neat, but so I'm multiplying this 1, I think I'm trying to highlight, times this 243 times this 1, and then 5 times 81 times negative x squared. I'm just going to color for a while. And so my final answer when I do this binomial expansion is going to be 200, whoopsie, what is that? 243 minus 81x squared plus 27x to the fourth minus 9x to the sixth plus 3x to the eighth minus x to the 10th. And this one, I know if I check here, my exponents don't add up to the 5, but that's because of that special case of raising that to a power. That's an extra one. Okay, this one wants you to find the fifth term of a plus 2b to the seventh. So you have a choice. You can do the whole expansion and raise that to the seventh power, but I really, really, really don't want to do that. So what I'm going to do is I'm going to try and go back and remember when we did the combination, we said that whatever term we're on was 1 less, so this will be 4, and then I'm raising it to the seventh power. So that's going to tell me my coefficient. So I'm going to do the 7 factorial over 3 factorial, 4 factorial. So that'll be 7 times 6 times 5 times 4 factorial over 3 times 2 times 1 times 4 factorial. The 4 factorials will simplify. The 6 and 6 will simplify. So I'll be left with a coefficient of 35. So my coefficient is 35. This also is the exponent of the second term, so I know I'm raising 2b to the fourth term, which means that this a has to be raised to the third term because the 3 plus the 4 has to equal 7. So then I'm going to take 2 and raise it to the fourth power, which is going to be 16. So I'm going to have 35 a to the third times 16b to the fourth. And when I multiply the 35 times 16, I end up with 560 a to the third, b to the fourth. Remember, whatever term you're on, you do the coefficient. This number is always 1 less. So this one is asking the same thing. What's the coefficient of a to the fifth, b to the third? Well, they're telling me that this third term. So they're telling me that for this 3b is being raised to the third power, which means that this a, which in this case is 2a, is being raised to the fifth power. To find the coefficient, it's going to be 8, 3. So off to the side, I'm going to do 8 factorial over 5 factorial, 3 factorial. And so that'll be 8 times 7 times 6 times 5 factorial. 5 factorial. 3 times 2 times 1, so the 5 factorials will simplify. The 3 and the 2 will equal 6, so this will be 56. So this is 56. To the fifth power is, oh, I'm sorry. To the fifth power is 32. And that's a to the fifth. And then 3 to the third is 27b to the third. So give me a second because I got to calculate that. So when I multiply the 56 times 32 times 27, I get 48,384. Then it's A the fifth, B the third, and that's the coefficient. Oh, it just wanted the coefficient, so I just needed this as my answer. That's an extra. Okay, and there's your homework. If you have any questions, I will answer them next class. If you have anything else, you can email me, and best of luck.